Welcome to my summer camp, advanced classes for class 10th class and all other competitive exams. In this class, in this video, I am going to explain acid and base in water solutions and an lab activity which proves acid solutions are good conductors of electricity, and what is an universal indicator, and what is pH, and what is the importance of pH. We will discuss all these things in detail and with complete lab activities. For lab activities, please click on the links provided in the description box. At the same time, I also request you, please like, share and subscribe my channel. Acid and base in aqueous solution. When acid or a base is dissolved in water, when acid is dissolved in water, it gives hydronium ion. It gives hydronium ion. See this, here hydrochloric acid HCl. When it is dissolved in water, it splits into H plus ions and Cl minus ions. Whereas the H plus ions do not have independent existence. That's why this H plus ion mixes with water to give hydronium ion. Hydronium ion. So we can say that when an acid is dissolved in water, it produces hydronium ion. Hydronium ion. So H plus and H2O, hydronium ion, gives rise hydronium ion. Not only hydrochloric acid, other acids also. Take the case of sulfuric acid. When you dissolve sulfuric acid in water, it produces 2H plus ions, and later it mixes with water to give hydronium ions and sulfate ions. These ions are responsible for the passage of current in the water, in the acid or base solutions. So, when a base solution is dissolved in water, it gives hydroxide ions. What happens when a base is dissolved in water? See this one. When a base is dissolved in water, it gives hydroxide ions. Remember that here acid dissolved in water, it produces hydronium ions, H3O plus ions. Whereas when a base is dissolved in water, it gives hydroxide ion. See this one, base plus water. When a base is added to water, it gives OH minus ions. See, here is an example. Sodium hydroxide, when dissolved in water, it gives sodium ion and OH minus ion. This is OH minus ion is known as hydroxide ion. What we call it? Hydroxide ion. At the same time, another example, see the case of potassium hydroxide, KOH, K plus OH minus. When potassium hydroxide is dissolved in water, it gives potassium ion and hydroxide ion. So, those bases which are soluble in water are known as alkalis. What we call them? Alkalis. Now come to the next one. In our previous class, we studied indicator. Indicator in the sense, indicator is any substance which tells about the information whether solution is an acid or a base. You can know whether it is an acid or a base. But what about this universal indicator? Universal indicator is a mixture of several indicators. It is a mixture of several indicators. So many indicators are mixed together to give universal indicator. So it gives different colors at different concentrations of H plus ions in the solution. Depending on the concentration of the H plus ions in the solution, it shows different colors. For example, you take the case of, if the concentration of H plus ions is more in the solution turns to red. The solution turns to red. If the concentration of H plus ions is less, it gives pink color. At the same time, if the concentration of the ions, H plus ions, is still less, it gives yellow color. So depending on the concentration of the H plus ions, universal indicator shows different colors. Now come to the point, pH scale. See, with the help of the indicators, we can know whether the given solution is an acid or a base, but you cannot judge the strength of an acid or a base. So to know the strength of an acid or a base, a scale was introduced which is known as pH scale. It was introduced by a German scientist Sorensen. Who is he? Sorensen. So pH, in pH, P means potenge, the power of producing H plus ions, the power of producing H plus ions. So pH is defined as pH is equal to the negative logarithm of H plus ions, the negative logarithm of H plus ions. See this one, the pH scale. Here I have given the pH scale. It varies from 0 to 14, in between 0 to 14. So from 0 to 6, the solutions are considered as acids. The solutions are considered as acids. Observe the colors also. See this one. Here it is thick red. So for a strong acid, it is thick red. So the pH of a strong acid is 0. Next one, 1, 2, 3, 4, 5, 6. So the solutions whose pH is in between 0 and 6 are considered as acids. The solutions whose pH is exactly 7 are considered as neutral substances, and the solutions whose pH is in between 7 to 14 are considered as alkalis, alkaline solutions. What we call them? Alkaline solutions are bases. So the pH varies in between 0 to 14. From 0 to 7 they are considered as acids, from 7 to 14 they are considered as bases, and exactly 7 they are considered as neutral substances or neutral solutions. So this is all about what is an universal indicator and what is pH scale, and pH scale varies from 0 to 14. At the same time, a lab activity is given in the description box. Please click on the links. Please click on the links to watch the lab activities, to know the importance of pH in our day-to-day life. Here I have given the links. Please click on these links here or in the description box. Dear students and friends, if you like my lesson, please like and subscribe, share among your groups. Thank you, children. If you have any doubt, please post to my WhatsApp number. Thank you. Thank you very much.